Hello, everyone. We'll be waiting for some more people to join in. But thanks for those in time. Basically, we have Mounir from Paraswap today and Merlin from Morpho Labs. So we'll be talking about securing DeFi protocols. I'll very quickly introduce DSS, which is a DeFi Security Summit. We have some exciting news for that. I'll be very quick, but basically we will, and we're very excited to announce that the DSS, the DeFi Security Summit, will happen right before DEF CON in Bangkok. So that's a very exciting news on our side. And yeah, last year it happened in, that was the second edition last year in Paris. We did it at La Maison de la Chimie right before SEC, and 2 years ago around the Stanford Blockchain Conference. So yes, this year around DEF CON, it will be about the same format, and we're very excited for this edition to come. Without further ado, I will introduce Merlin as our first speaker. He's a co-founder at Morpho Labs. They just released their new protocol, Blue, that he will talk about, and he will talk about security measures that they took and much more. So I will give him the mic, and feel free to ask your questions in the chat, and we'll take 5 minutes at the end of his talk to go through them. So thank you very much, Merlin. The floor is yours.
All right. Hi, everyone. So as Nathan say, I'm Merlin, one of the co-founder of Morpho Labs. We've built first the Morpho optimizers that are like kind of lending protocols built on top of lending pools such as Aave and Compound. So there's close to $2 billion of dollars deposited on those protocols, which make them the third biggest lending protocol on Ethereum. And recently we deployed the Morpho Blue protocol that is totally independent, so not built on top of other lending pools. And it's we wanted it as like kind of a lending primitive. And so I guess I share my screen and give a few slides, but because when it comes to creating a primitive, you need to take drastic measures to make sure that everything is like is perfect and there's no bug in the code, because like you want to have like people that you're sure that when they are building on top of your protocol, everything is safe. So I share my screen. Do not hesitate to ask questions. I'm not sure I'd be able to see them, so maybe I don't know, Nathan or you can tell me like
Yeah, we'll pull them through.
To do it. So what I'll show you today is like what security framework we use for Morpho Blue, and maybe I can say also what are the difference like compared to what we use when building Morpho optimizers. So as I said, like we've built the Morpho optimizers. I think the first one was deployed like 2.5 years ago. On the first one was on Morpho Compound, so Morpho optimizer built on top of Compound. And during those 2 years, that was super exciting. But we realized a few things. Is like in fact, when you build very close to other protocols, you are exposed to all the things, all the features, all the governance decisions that are made on those underlying protocols. And what we realized is like, in fact, Aave and Compound were like very, very large code base, like a few thousand lines of code. So I think it's like 5,000 for Compound and like 7,000 for Aave. And because they are like very large code bases, like sometimes there are a few bugs, or like sometimes the protocol needs to be paused because there's kind of a rounding somewhere, so it needs to be upgraded. The flash loan system has a problem, same thing. And there are also many features like stable rate, emode, etc. within the same infrastructure. And so, which leads to frequent bugs in production. And what happens is like some weekends or at some moment, like the Aave or compound operator will pause the protocol, and we need because we are built on top, we need to do the same, like pause to mirror what the underlying pool is doing. And this is like it drains energy. It like it unfocuses your team from like building, because like you need to monitor everything. And in fact, we ended up like realizing that the current DeFi protocols are not trustless. Like it's like the whole DeFi values are about like a censorship resistance, like trustless systems, etc. But in practice, like there are always like some operator that can like post things, etc., upgrades, and also there are like a kind of like a more risky system that what they appear. Like you think like the user experience when you come to a DeFi protocol in general is like very passive. You deposit your tokens and it generates yield, and you don't need to do anything. But in the background, in fact, you have some risk managers that are managing the whole thing and like deciding like some risk parameters. But it's like a one size fits all. So even if they are like, you may be a degen or like a good father's family, and you can have like very different risk profiles, but you're still exposed to the same risk measures. And for instance, as a pure USDC lender, you're exposed to all the risky assets that are listed on the pool. And so we realized that during those several years building on top of those protocols, and we ended up like conceptualizing secure protocol requirements based on like those drawbacks that we've noticed and witnessed in the current protocols. So what we ended up like thinking about is like protocols when it comes to create a primitive, so kind of a base layer on which you want everyone to build on top, and it's like fully trustless, and they builders don't need to worry about like whether they will shut down this feature or upgrade or whatever. You drastically need to decrease the attack surface, and each time you add a feature or like a fancy thing, like you just increase that attack surface. So whenever you as a protocol builder, designer, whatever, one important question is like, if I don't include that feature, will user not use my protocol? And if the answer is like no, they'll still come and use that protocol. So a good thing is just to remove that feature, because like you just if you keep it, you're just increasing the overall complexity of your protocol, and you might end up like just being hacked, which is one of the like starting a startup is very hard in the general world, but in DeFi you also can get hacked and pretty fast. So you're just increasing your likelihood to get wrecked. And which comes down to minimalism, in fact. And in our point of view at Morpho, is like a protocol can only be minimalistic, and it cannot have like fancy feature and like overkill things. Yeah, so that's it. So here we are still in the pre-build phase. So we didn't write any code, etc. So we are just like thinking about what we want to have in the protocol. What are the things that we want to fix? What are the problems we want to solve? And also, before writing a single line of code, like of course you have the protocol design. But during that protocol design, like one thing that is important to do is like sometimes you can see like sometimes our people are referring to threat modeling, where like the goal is like to raise what are the different threads, what are the different stakeholders in that protocol. So I don't know, like on the lending protocol, you have like borrowers, lenders, risk managers. But you also have like strategists and the market, the oracles that that can update prices, etc. So you have multiple stakeholders that can affect how the lending protocol behaves. And threat modeling is about like just identifying first those all those stakeholders and like how can they affect your protocol, and then raising concern before they happen, like how here are the list of like if the oracle is broken, like how can it affect my protocol, and what are the steps that or measures that can take to make the protocol safer and like more robust and resilient compared to that stakeholder. And you can do that for all the stakeholders. And we are not doing that very formally within Morpho Labs, but what we created instead is kind of a culture where any concern can be. So I'm very speaking about like how Morpho Labs is working internally. Yeah, let me come back. So we have like kind of culture of debates, so and open criticism. So everyone can say like, oh, I think here we are doing a mistake, or I don't like this feature, or I don't like the design choice that we did. And even like intern within the company can say that, and it's like very open. And we try to keep that because then like everyone can bring their own point of view. It's like you can bet on like say like the intelligence of the collective to end up and go toward like more mindful and better decisions. And yeah, on the short term, you think like you're losing time because like maybe just one or two person could take the decisions, and like you'd be way faster. And like that's true, but it could be way faster, but in the wrong direction, like just going straight into a wall. And that's not the thing that you want to do. But on the long term, if you take even like the lifespan of the protocol, which can like take years, etc., you're just like saving a lot of time, because like you'll make like a much better decision very early in the design process if you have like an open culture and like everyone can debate. And we are spending a lot of time like debating like even like tiny things, and naming things is like small details. Then in fact, after this, so let's say you have like designed your protocol, debated a lot, and now you have all the requirements, you know where you're going. Then you enter the build and test phase, where you'll just write the first lines of code and try to test the whole thing. So of course, like maybe like everyone know about it, but I think it's good to emphasize like the very basic. So the first thing is like write a lot of unit and integration tests. So that can be done in parallel of the development of the protocol. Why I think it's better to to do it in parallel and not like write the protocol in full and then try to test it. It's like sometimes you realize like some design choices that you made in the early process, like during the pre-build phase. In fact, they don't hold that you made a mistake, or like you realize that there are new issues that you didn't think about. So like testing in parallel of building like will really raise those issues very early in the process, and I think it accelerates overall the different iterations. I think like yeah, for integration tests. So just as a reminder, I don't know, like perhaps like everyone knows, but unit test is like you test like a very small component, like how single function behaves, and while integration test is like more testing a combination of like different functions, or like the interaction of your contract with another contract. Both are very important, like and integration test, like I recommend it, like if you want to deploy on the on a network, to try it in a fork, and not just like mock everything. Why? Because like sometimes you will end up like finding these small edge cases, like I don't know, for instance, USDT has no Boolean return value, which is like at the opposite of like the ERC20 standard, or it's the opposite. I don't remember exactly, but if you do some transfer in a fork, then you see that if you try to transfer USDT, it will reverse. And if you don't do it, like ever you already have this knowledge, which I think it's an important knowledge as a security researcher, but it's okay, it's well known for USDT, but you may have other edge cases, like if you integrate, I don't know, Balancer or any other protocol. So I really recommend like trying doing integration testing for. I didn't mention it, but one thing that is important is like checking the coverage of your code. I know that coverage is not like it does not mean it's not because like you have 100% of test coverage on your code that you're done, like your job is done, like you won't have bugs in prod. But I think it's like still a good thing to make sure that you are exploring all the benches. And one way to do it is like with Foundry, you have forge coverage, which is nice. You can create reports of that and identify like what are the missing branches. And also, yeah, there are like some tools, vertical.rs and Gambit, that are tools, mutation tools. And mutation tools is like a new thing that we tried this year for Morpho especially. We didn't use it for optimizers, but this is a cool tool because what they do is like they try modifying the code and running your testing suite on that. And if the mutations of the code pass the test, while like there literally changes the behavior of your code and the test pass, it means that you're obviously missing a test, and this can like spot some hole in your testing suite. And I think it's very cool. There's some development around that, and I really want to have like some advancement, to see some advancement this year on that kind of tool. Of course, you should use you should fuzz your test. So sometimes it's like useless, but it's very good, and I mean it's very easy to set up, especially with Foundry. So there's no excuse not to do it. Yeah, it's very important. You'll spot plenty of bugs with that. But I go fast on that. Internally, what we have is like we have we have two teams, in fact. we have the protocol team that is like more focused on like designing the protocol, writing the protocol, and testing also. And we have the integration team. So now I'm leading this integration team that is more focused on supporting integrators. And what we are doing is like we are conducting security reviews for those integrators, but also we are doing reviews for the protocol. And sometimes we're writing contract. But the general rule is like if one team is coding, the other team is reviewing the code, and vice versa, so that we always have like internally fresh eyes that can like criticize and review the code. It's like kind of a red team, blue team within Morpho Labs. And this has proven to be quite powerful to find bugs and like and debates around the design choices. And one other rule is like everyone should review all the code that we deployed, so that like there's no single point of failure. There's not a single person that has all the knowledge. Like every single engineers that does like solidity engineers within the company should be aware of the whole code base that have been deployed. And this is very important, like because over the year you can like people that are leaving the place or coming in, and you don't want to end up in a situation where you have like, I don't know, a bug in prod problem or something to update, and the person that has had all the knowledge is gone and is not there anymore. So this is important to have. And so during the build phase, once the code is pretty pretty down, actually, we call advisors or VC researchers for peer review. So which has a new layer of like a security reviewer, solidity engineers looking at the code that will challenge the design, the code, etc. It's very important to have the more eyes, the better for your code, obviously. And then about invariants and formal verification. So invariants are like are quite easy to set up using Foundry. It's very fast to implement. So if you have like some invariants and like mathematical things like that should hold during the whole lifespan of the protocol, then you should like just write some Foundry invariants. Something that is more powerful is like use like a formal verification, for instance, using Satura. It takes a lot of time, though. So maybe with invariants, you'll catch most of the bugs and that are related to invariants. But Satura is like much more powerful. Fortunately, internally, we have someone that has a PhD in formal verification, so he's doing like the whole thing, and also working with the Satura team to do formal verification on Morpho Blue and other contract that we ship. It's an endless workshop because, like, obviously, there can be an infinite number of invariants. So even after deployment, we are still continuing working on the formal verification aspect of the protocol and continuing to prove some invariants. That's it for that part. And then after, when we have written all the code that we've secured it, we have written a lot of tests, etc. What we do is like, because it's like the protocol will be is like every year, year and a half, even 2 years. It's like it's quite a particular event. So what we do is like before going into the audit process, etc., what we do is like a big bootcamp with the whole team. And what we do is like we gather everyone just to share a moment where it's not like a chill moment. We'll just like try hard. We'll make sure that everyone has the protocol's vision, is ready for the launch. But also like the engineers, all the engineers will try to break the code. It's like we go in a remote place and we try like, oh, can I attack the code? What can I do? And try to, yeah, we try to go into a hacker mindset and break things. So it's one of the most cool, like one of the best moment of the year. Then, so we've built the protocol. Now we are entering the pre-deployment phase. So during the pre-deployment phase, we've started with like tier one security reviews, one from OpenZeppelin and one from Spirit. We've Yeah, I'm a huge advocate of like the Spirit team. We've worked a lot with them, and it's like they have a pretty good team. And the goal of those security reviews is like to have external security researchers looking at the code to find like the major flaws in the code base. Also to receive some feedbacks on the design choices. And yeah. Usually the security review should be long enough to give some to give time for security researchers to look really deep into the code base and like to make sure that they understand everything. The best what I would advocate is like to do the security reviews sequentially, so that you do the first audit, you fix it, and then after you do the second audit. Sometimes you can't because you just don't have the time, or like timelines that does not fit. In a bear market, you'll see it's like a way easier to like schedule an audit, but when it's a bull market, like everyone wants to deploy their new protocol, it's super crowded, it's like price is super expensive, and it's very hard to find a place. After that, we did a contest with Cantina. We put like a 200K at stake. It was like so I don't know if you know Cantina, but basically it's like it's a C4 Coderina competitor or Sherlock or whatever. Like they are all competing in the same space, like about like security contest. And this is very powerful because like how I see that is like it's kind of a giant human further, like where you have many people like trying to break your code. It's like very efficient, but usually it's like on a much shorter like span, and like it's a matter of it's like shorter than like standard security reviews. So sometimes like people won't spend as much time like as security researchers in like standard audit companies. So it's kind of a different game. So I think it's important to have like both and not just do one audit and one contest, but it's important to do both. Obviously, it's something that you can do if you have enough money. The limit for security for you when you're building protocols like money and time. The larger pot, the more you incentivize the best to come and look at your code. That's obvious, but so yeah, try to have like a high pot, and also like to find a slot where there's not so many contests, so that like it's not so crowded, and I hope like you won't end up like doing your competition during I don't know. I think like ZK Sync offer like a 1.1 million at stake, and like recently Blast offer like 1.2 million. So obviously, it's like if you don't if you put like 200K when there are those kind of competition, like you may not have the best looking at your code, but it depends. Also, during the competition and like audit, what we're doing is like thinking about the incident response plans. So incident response plans is like it's kind of a playbook, a recipe that you should follow when something bad happens. Like and I think it's Nascent did like a super good playbook that you can take inspiration from. This is where also you can leverage what you did during the threat modeling, your threat modeling sessions. It should be super simple and efficient. Like you should not like think too much about what you're doing because like you're just running against time, and what you need to do is like I don't know, pause your contract or like reach out every stakeholders or like I don't know, risk managers or users. You want also maybe to contact authorities. For instance, like on our side, like we have direct contact with security researchers, with Chainalysis, so that like if something bad happened, we can jump into a dedicated channel and like trigger all the authorities in the world or whatever, so that they, I don't know, like USDC could be frozen on Binance, and so the guy, if he wants to exit, like it can be blocked, etc. And you can prepare a war room for that in advance.
Merlin,
Yeah,
just
I don't know about the time, so I don't know. Yeah,
yeah, we have 5 more minutes left. Awesome.
Yeah, I think it's good. And then after we did like a pre-deployment bug bounty with Ads Finance. So it's like when you did all your security reviews, all your competitions or whatever, the code is frozen, but it might not be deployed yet because like I don't know, your interface is not live yet, or like there are always things like that just push forward your release date. So what we did is like we put at stake some money. It's kind of a bug bounty, but the code is not live yet, so that you can still incentivize people to report some bugs before you deploy. For instance, like Morpho Blue is an immutable contract. You can't upgrade it, so it would be very annoying, like if someone find a bug just after the deployment when you did like the whole launch and release and release. So I think this is something that is it's at least an added layer of security. Then you've deployed, congrats, and you have like the two things the most important things to do is like monitor your contract. So imagine you have all your environments. So this is very important. Like for instance, you set up bots that are like running some environment check, and you can do it like for instance at each transaction that are sent to your contract, just to make sure that this transaction has not broken any environments. And that can be quite easy to set up, and this is something that you should do. Also, what you can do is like at the very beginning, you can even log like every transaction and just like to understand like what's the user behavior, etc. And after you can like create some specific monitoring where like the transaction is like using more than 10 million or 100 million dollars, like just rate the event. You have also a bunch of solutions in the space to have like some things like that are fully automated, like Forta, Defender, etc., so that you can use and set up on your side. There are many things that we do internally because we really understand how the protocol behaves, and so we really want to have also specific monitoring for specific things. And for Morpho, there's no, it's governance minimized and immutable, so there's no secret breaker. We can't pose anything, so the only thing that we can do is like monitoring very closely and have like very fast incident response plans where we can like warn users and risk creators that there's a problem, if any. And then put a bug bounty. So for now, our pre-deployment bug bounty is still live. We'll announce like the bug bounty for Morpho, the 500K bug bounty, sorry, for Morpho in a matter of weeks, I think. There's already one for Morpho optimizers. It's very important to have that, have one. It has been useful for us for the optimizers, and I don't think it's possible to add like a live protocol without the bug bounty, to be honest. Like it's just like you're just calling hackers to hack your protocol, and yeah, you should definitely do that. And also one thing that you can do is just like stay in sync with what's happening in the space, like what are the new security measures, etc. Like there are a lot of things happening, like new hack that are the type of hack that are discovered, etc. And so sometimes like a protocol or a code base that was safe, it's just like people realize like, oh, but in fact it's exposed to the same bug as this new rounding based attack. And so you should like continuously learn about like new hacks, etc. On our side, like for instance, we have done something like every week or 2 weeks. What we do is like a hack school where one engineer is just picking one hack in the past, and like it is just trying to explain it and like really deeply understand like why this hack happened and how, and also like understand like and make sure that Morpho's contracts are not exposed to those kind of attacks. So I think it was like, yeah, I have the recap, but so you have those 4 phases, a bunch of things like you can do. You have that image of like I should have put that, but this image of like the Swiss cheese security layers, where the whole Swiss cheese layers has hole, but if you combine them and put them together, at some point like it's like nearly impossible to hack and find the vulnerabilities. Of course, like you can always find things, but the more layers you had, the better for your protocol and your users. Yeah, questions? I don't see the chat, so maybe.
Thank you for that. That was really awesome. Yeah, I'm sorry for the late join here. I'm going to be moderating. I'm Elliot. Okay, so the QA. So for testing, would you rather use forks or any testnet? I imagine forking mainnet gives you the latest version of dependencies or external partners, but appreciate having your input.
Yeah. To me, like forking, like to be honest, like forking is really the way to go. So I think like at the beginning you can use like a local fork or whatever, but I think like forking mainnet is very important because like I said it during the presentation, is like I think this is the best way you can discover some edge cases, and it happens like not all standard or are met. Like okay, there are some vault that are ERC 4626 compliant, but sometimes like you realize that they are compliant-ish, and that sometimes like you have like something that are different, and if you just like you're just testing like your dream environment, in practice it's not like that. The real life is like is not nice, and you'll, yeah, I definitely recommend to use fork.
Yeah, I guess another question is, what are the biggest security lessons learned from building optimizers that you've applied on Blue?
Yeah, I think it's like the first thing that I mentioned is like about minimalism. It's just like if you really want to create a primitive or protocol that is trustless and that is supposed to like be kind of the internet protocol, it should be very simple. It should have like the very strict minimum. It should do one single thing, but do it perfectly. And if you're like adding many features, like as I said, you're just increasing the attack surface and like the likelihood that you'd be hacked. And what we saw is like a very large code base as our all had at some point one issue and had been upgraded or whatever, but they whole had issues. So I think Morpho Blue, to be honest, like we have like between 600 700 lines of code compared to like a few thousands, and we really worked a lot to minimize the amount of lines of code, and it was like yeah, really important. So minimalism, if I just I would keep one word.
Yeah, I think that's really important. And when the code base was announced, I took a look through it, and I was quite impressed with how few lines of code and how simple the architecture was. And I think that's something you see a lot from top teams, is you want to reduce the amount of branches and the amount of states your contract can be in. And you talked about integration testing with Foundry, right? If you test, you want to test all the branches, but actually, even if you do like integration testing, you may not even test all the states your system could possibly be in.
Yeah,
as you increase your complexity. So, yeah. Okay, so we have another question here. They want to know if you employ any penetration testing tools to simulate past hacking incidents on your decentralized application.
So we are trying to so in general, it's like scenarios that we identified during like writing code. Like I don't know, during the pre-build phase, like you realized, oh, we can apply that kind of hack or something like that, and then we'll write this attack and make sure that it does not pass anymore. But we are not like trying to pick one, say like I don't know, cream finance hack and trying to like pick that attack and use it on our protocol. But we'll try to get some inspiration. It's like I talk about the hack school, etc. And this is where we try to find some inspiration, because after, in general, what we debate and we ask questions like, okay, could we apply that on our contract? So obviously we do it when hacks happen, but sometimes you forget or you don't spend enough time. So here's like a place where we can we take and just thinking about like to what extent it can affect Morpho.
Yeah, I think that it's great to learn from the past mistakes so you don't repeat them for sure. They're very expensive. So the next question is, you mentioned you do invariant screening on transactions. Are you doing that in real time while transactions are in the mempool, or after a transaction has been
No,
processed?
it's after the transaction has been processed. So it's not like a proactive detection. And so I think it's like first like not like a hacker sometimes also don't go to the I'd say the public mempool. So it's not obvious that we would catch up anyway all the transactions. But we have like a talk about Forta, but there's hyper native and those tools, and like they are kind of specialized in like threat detection, etc. That are like more general tool, sometimes applying AI or not. But for like invariant testing is like after the transaction.
Awesome. Yeah. Well, Merlin, thank you for coming up here and sharing your insights. I think that a lot of teams could learn different parts of what and take certain parts away and apply that to their development lifecycle. I think that there's a lot of great things around having a culture of rigor, doing as much testing as possible, getting a lot of code reviews, lots of tests, formal verification. Yeah.
One thing is like the content like that I said, I think I will release an article on that that is summing up everything. And one thing is like I think it will help people like just like wannabe builders to like to have a clearer mind on like how to set up a good security framework, but also like receiving feedback from like security researchers on like how can we improve things, and it's like just opening the debate. So I don't know when we'll release that article, but I guess I share on the DSS Telegram chat and yeah, I think it could be a cool starting point.
Yeah, please keep us posted. And yeah, Merlin, thank you so much for your time.
Thanks, Elliot. And thanks Nathan as well.
Okay.
I don't know where to switch. Like maybe you shut me down and
I'll do it.
Thank you.
Next, I want to introduce Mounir from Paraswap. He is the founder and CEO. And Mounir, the floor is all yours.
Yeah, thanks, Elliot. Do you hear me well?
Loud and clear.
Okay, perfect. Let me share my screen. I'll start with that. My screen is visible.
It is loading, I think. I'm just seeing a black screen.
Same on my side.
Okay, 1 second. Let me check. Yeah, I can just upload the slide very quickly. Just a second. Download PTX. It was supposed to work, but okay.
It's all good.
There's definitely been a few technical hiccups in getting this set up, so you're not alone.
Okay, loading. Okay, how about now?
Yep.
Perfect, yes.
Awesome.
Okay, perfect. So hey guys, thank you for coming here. I enjoyed the Merlin talk. It was really, really great. So I'm here to talk to you about our experience at Paraswap, what we've learned around like 4.5 years or more running Paraswap and scaling Paraswap, and also Porticus, the new intent protocol that we announced around 2 weeks ago, and what are the opportunities and issues that we identified and what is our response and our plans in order to solve and to scale intent protocols. So just very quickly about Paraswap. So we are a decentralized exchange aggregator. We've been running since late 2019. We processed over $60 million in volume, and most of it came from third parties that use Paraswap as a piece of infrastructure or as a tool among their tool set in order to provide either the best trading experience for their users or maybe fulfill their own needs for trading or liquidity for their own purpose. And I would like to spend some time talking about the architecture and some design choices that we did in Paraswap. And here it's a diagram that shows the user flow and also the two main components when using an aggregator in general, not just Paraswap, and also some DEXs that build routers like Uniswap and SushiSwap and others that kind of use more or less similar architecture. So you have the off-chain components that you see on the top and the on-chain components, which are basically the smart contract for trading. So if we started with the smart contracts, in our case, in case of some other DEXs or aggregators, we have two contracts, one used for trading, we call it Augustus in Paraswap, and we have a second contract for approvals that gets the allowances for the users. And I will explain why we have this design choice, and that's something that's going to be discontinued in the V6. It's because of, I don't know how good you can see, you can read, but it's not very important. So the most important is like how this works. We have a function called Simple Swap, and that's dates to the very first day that we launched Paraswap. It allows for swapping tokens, and we call it simple because it swaps token without intermediaries. So if you have like ETH to DAI, it's going to use one or multiple exchanges to perform the swap without using one or multiple intermediary tokens like a USDC or USDT. Thing is, that simple swap, as you can see on the right, if you can read the code, it uses external calls like arbitrary calls. The big benefit is it allows to have full off-chain integration of DEXs. So you can take any DEX, take the execution functions, and implement them on what we have. It's called DEXlib. It's an open source library. And the integration can go very fast. So early days, it allowed us to have integrations that can take a few hours to maybe 1 or 2 days. The big downside is that we need to have two contracts, one for the allowance and one for the swap. The reason is if you approve the same contract, well, for the developers, as you can see, you can still pass arbitrary data that will have access to the allowances and well, basically wipe out user wallets. And there are two major cases. One is known and the other one is less known. The known one is an aggregator launched last year. And the very, very first day that they launched, they went for a naive design with one contract and one only contract. And they got hacked from day one. I think their users lost a few $million. In the other case, we found in 2019 in one of the competitors that they had this similar design, and we were able to build a POC where we were literally able to wipe out user wallets. So that's okay, but the point I'm trying to make is developer experience is very important because it's easy to make mistakes. It can be from the builders of the protocols like ours, where they may miss a very critical design piece like this, or also the integrators. We found last year a developer that they didn't read the docs, that we have a big warning that please don't approve Augustus. You need to approve token transfer proxy, but they just went ahead and approved Augustus, and somebody was watching the blockchain and they took something like 80K from them, which is like quite significant. So I think this is one of the motivations we decided in the V6 that should be coming in a few weeks to completely remove this design choice. We found better ways to still have good gas competitiveness and speed of delivery. But yeah, that was a big lesson learned, especially on the developer experience. That was okay for us. It allowed us to iterate quite fast, but at the same time led into some issues, especially on the integrators, as I said. But in general, the architecture works like this. It's a diamond architecture where you have multiple routers. So what we did in that's a V5 design is each router has its own contracts, and behind each router you have DEX integrations, what we call adapters. And that's a design that's quite flexible, that allow us to add new routers for like I don't know, tomorrow we discover a new algorithm that we can add quite easily. And also one example is Balancer that we added last year, and that turns out to be super gas efficient, where it was added as a router instead of as an adapter, as you can see here, and that was quite beneficial for users and for developers who integrate our tech stack. Wanted also to spend some time on the off-chain parts, one on the performance and scalability, and the other one also on security and what can go wrong with off-chain services, especially UIs. So the very first days, we had a full on-chain Paraswap. We had one smart contract that we called Aurelius, and Augustus for swaps. Aurelius, I mean, there were only 4 DEXs at that time. You can compute prices, run the algorithm. I mean, there weren't that much liquidity pools anyway, so it was more than enough, and it was very fast and scalable. Nowadays, we have hundreds of exchanges. We have tens of thousands of liquidity pools. So doing that on-chain is just simply not possible, or at least it's going to be suboptimal. So we end up with 2 choices. Either we'll build the integrations. Like we have DexLib that I mentioned before, that has like integrations of the logic behind each DEX and a representation, off-chain representation of the state of each DEX. Or we use RPC calls, like for instance, take Balancer and Curve to compute a price. Well, what you can do is like make a RPC call for a get price function, and doing that is just simply not scalable. That's why we built DexLib, which is like, as I said, rebuilding the whole state off chain. So for instance, computing the price of ETH to DAI, it's not just an ETH to DAI computation, it's ETH to USDC to USDT, like a bunch of connectors where you need to compute the price in order to build some kind of a graph that will allow you as a developer to find maybe a potentially best possible optimal price. And doing that using RPC calls is just simply not scalable. We know that's like it was a practice maybe a few months ago, like more than a year ago, but nowadays, as much as more and more DEXs and more innovation in the space, it's just not possible. So here with DexLib, we're able to have in-memory calls that are millisecond or sometimes sub-millisecond time to arrive into the most possible optimal price. The rest of the time, like the 100 or 200, 300 milliseconds that is spent end-to-end from the user and the back and forth to the server is about networking and not computation. So that was something that was super interesting and allowed us to scale, and we see this practice more and more happening in other places. But yeah, so running off-chain services is cool. We use some techniques that are very well understood for ages. But the thing is, in the Web3 variants or segments, there are some things that are very specific and many things that can go wrong. And most known issues that we've seen so far is, well, users using UIs and giving allowances to the wrong contract or trading with the wrong contracts. There are things that we cannot do, right? If there's DNS hijacking, well, there's so much we can do because simply there is no more control. Obviously, other best practices have to be adopted in order to avoid that problem in the first place. But it's so much we can do. But the things we can control, at least in our side, what we do is hard code those addresses as much as we can. Obviously, I'm not gonna talk about the best practices. I think Merlin had an amazing talk about what are the best practices to implement internally in order to avoid potential security issues. But admitting that this is the right practice. in our side, for instance, for addresses, for allowance, and for the contract, there are multiple checkpoints. You have the API that has a hard-coded version. You have the UI also that have another hard-coded version, and they have to match. If it doesn't match, the UI should crash or like should not allow a trading to happen. The same for the allowance. There is the hard-coded versions, the address, sorry, that should be fixed. They should be immutable, but also it can be dynamic. So you have 3 checkpoints in order to make sure that the user cannot miss that address, or like at least the UI cannot miss that address. And that's also practice. We recommend everyone that will use our API or our like a tech to adopt similar practices. But something else that look less like a security or like classical security issue, but can lead to a huge fund loss, and we've seen that a lot in the space, is in trading, of course, is a big price impact. Some people call it slippage. In reality, slippage is something that happens on chain post-trade, but price impact is I'm selling something that's worth $1,000 and I'm receiving something that's worth $10. That's a huge slippage, like more than 99%. And sometimes what happens is you have APIs like ours who you have a payload on the response that contains a USD amount of the from amount and to amounts, but this API can go wrong, can have bugs, and it can lead to a UI that's blindly trusting that API to tell the user that, hey, this trade is fine, just go ahead and trade. And the user will be surprised to see in Etherscan that they lost 80, 90, 50% of it, something that's quite substantial. So what we recommend, and at least what we've done on our side, is you always independently on the user interface cross-check or double-check using an arbitrary oracle, can be a Chainlink, a CoinGecko, or you name it, that will double-check the USD prices and compare it to whatever it's received from the API, and also blocking trades when price impact is significant, is quite high. There are also various ways to compute the price impacts. There is the traditional financial way, which is taking the price of a small amount and comparing it to the amount that's received by the user. For instance, very simplest one is I'm selling something of 100, like 100 DAI. So I will compare the price of a 1 DAI versus 100 and see what is the impact. Like, is it a 1 or 2 or 3%? It's hard to implement because there are a lot of moving pieces and also API rate limits and all of those things. So we take a very conservative approach of using a USD, which is quite simple and it fulfills more or less the same objective. And yeah, and the rest is user experience, that blocking trades at a certain threshold, displaying warnings, things that have led to mitigating those kind of issues that happen to us once and happen to other UIs a lot of time. And we see this still happening till today in the space. But we believe that those practices that we've learned enabled us to never see any issue, at least on our side, for the last 3 years or more. Yeah, so I think that's it for Paraswap. Now I'm going to talk about the intents and the work that we've been doing for the last few months, that we started in around late summer of last year. And so I guess many of you guys must have known how intents work and what are intents. Basically, an intent is an expression of an intent for doing an action and delegating this action to a third party that will try to fulfill that action to the most optimal possible. An example for trading, like I want to trade a token A for B, instead of using swap platform, or it can be Uniswap, Paraswap, or anything else, of me going directly on the contract and swapping and fulfilling the action and paying the gas, I will put a third party or like delegate this to a third party. And that third party, its role is to provide me something that is better, like a better price, better execution. Better execution in this context is especially MEV resistance, and also a great user experience like gasless transactions and all of those things. Example is swap. It can be limit orders, yield optimization. Use cases now are popping up every now and then because it's simply something that's like a superior design compared to what we used to have before. And we'd like to talk more about what we are. Presentation I think is not showing quite well. But anyways, I'll do it already. So the current way, yeah, sorry for the slides. The upload didn't make it quite clear. It looks much nicer in a Google Slides. But in general, the way intent protocol work today is they perfectly solve the user experience problem by abstracting gas and making the transactions MEV resistant. And the way they work, you have an end user, an intent API, and a solvers, what we call solvers. Some call them resolvers, fillers, fulfillers. There are many jargon in the space, but at the end, those are entities. It can be individuals or market makers who have some skills or some liquidity and are able to compete to provide the user the best possible price. And they are the ones responsible for executing this trade. And the way they will win the trade is through an auction that's run by a intermediary that we call here an intent API. And that intermediary is the one that will receive the intent from the user, build like an off-chain order book, and forward or like create the auction for solvers and select the winner. Problem with that is that entity, well, it's a centralized entity. It can go down. It can be biased towards who wins or who doesn't win. It's not censorship resistance. So it's fulfilling its needs to vis-a-vis the end user. The problem is how this is DeFi, or how DeFi is this, or how scalable and decentralized is this. We think that we can do much better. So this is where the design of Porticus that we are working on right now, where we are introducing or replacing that centralized entity or that centralized API, but what we call here DL, decentralized layer. We don't want to give it a characterization yet because there are various possibilities, and we explored like the upchain possibilities like Cosmos, OP Stack, you name it, still looking into other possibilities. But the basic idea is that it's not up to an entity or a centralized entity or a team to fulfill those user auctions, user intents, and select who wins, who doesn't win, and not be censorship resistant. We want the opposite side. So this is where the DL will play this key role. But of course, when we talk about DL, if we suppose here that will be an upchain. Upchain, it means that there will be maybe a gas that has to be paid. So the simplicity or the great user experience we introduced in the beginning, we're gonna remove it by introducing a new complex piece of architecture. So this is where we thought of this new component called relayers that will make it look like as if nothing was changed. Like, so for a user, they can still use a relayer that is an API, a centralized API, an off-chain API. But the big difference here, it will be that this API or this relayer or this intent API is optional versus a mandatory one where the user doesn't have any other recourse but to use that intent API. So similar to like accessing Ethereum. Today, if you want to access Ethereum, yes, you can have a get and go to console and run your RPC queries, which is not something that normal users do. But not what normal users do. They will use a wallet, which will use a Alchemy, Infura, you name it. But it uses any of those relayers. Like it can use any RPC provider. It can fall back to another RPC provider. There is not one RPC provider. There are many, and that's the idea and the philosophy behind the relayers. But very quickly, also the way we like to build software, that's also very cultural in Paraswap since day one, is always going lean and never trying to build everything from scratch, from end to end, and always having an iteration. The simple swap that I showed in the beginning was a good example. So also being realistic and aligning with the user expectations. So users, we agree that they care more about what is it for them, like great execution, good user experience, protection from MEV and all of this. So this is where we built stages that's also inspired from Ethereum, Optimism, and Co, in order to break down the deliveries into various phases. So phase one will be a design that will be quite similar to the existing products. And the end game will be to build in a fully decentralized layer that we call the DL for now, in order to deliver this fully decentralized trading experience. We call it intent today, but yeah, we would like to see it as this is the future of trading, where everyone is self-sovereign and there is no third party or entity that can censor or can be biased, or it can be just simply not decentralized. Yeah, that's it for me. Thank you, guys. Happy to answer any question. And
Thank
sorry
you.
for the slides.
All good. I think that's yeah, it was tough getting things set up. So yeah, and I think that there's definitely a lot of similarities between, I feel like, the philosophy that you and Morpho have in terms of like minimalism and user-centric design, yeah, and making things as simple as possible. I think that's a really important piece when developing this kind of software. So we have a question from Andy. He says, what security tools or mechanisms does Paraswap use today?
Well, we have the best practices that Merlin talked about. A few things that we haven't used, like Certor, I think we explored at some point. Maybe it wasn't the best fit at that time. Also, we don't have the same security profile. Like if you're holding user funds, you have a much bigger risk, and you'd better also be quite careful and maximizing on the security side. Also, aggregators are quite simple, and we try also to oversimplify to make them even more simple. And as we discussed before, the higher the simplicity, the less the attack surface. The code that executes has like one entry point, which is like the parameter for the trading, and you have a final check that checks if the user is received what it's supposed to. So if I'm trading 1 ETH and I'm expecting 3K DAI, doesn't matter what's happened in between. What matters is, did I receive exactly 3K DAI? If not, I revert the trade, and we get the guarantee that nothing is going to happen beside the gas that was traded. So simplicity is important, but yeah, we didn't want to bore you with like internal practices of internal review, audits. We adopted recently with V6 this sequential audit. So we did the first audits of V6, was okay. Then we scheduled the second audit. That's why we're taking extra time in order to. We tested this model, but it's funny to hear that we're not the only one that went for this sequential audit instead of like making multiple auditors in competition.
Awesome. Yeah, and I think that in your talk you also addressed concerns around like the slippage and just allowances, making sure that users aren't approving too much the protocol when they shouldn't be, or making sure that the arbitrary call data that the user is passing to these contracts is doesn't allow any sort of fund transfer that shouldn't be happening. I mean, I would love to hear a little bit more about the new system and like the security practices you guys are taking there. We might have one more question.
Yeah, I think I see a question about Relayer is a good place, or not Nathan asked a question. I'm curious about the biggest security challenges in particular to bring. Or is there anything before I don't see them?
Okay, a question came in here. How is the whitelisting of DEXs done in the aggregation? Do you choose to display DEX A and not DEX B? If this kind of whitelisting is done, of course. From Merlin.
So there are two kinds of whitelisting. Is this like for integrations or for like adding support for a DEX, or is it for like security? DEX A, not DEX B. Maybe this is for price computation, I guess.
Yeah, I think it's probably for like integration with the front end and.
Yeah, it's just like you might be exposed to some risk when you're routing user to a specific DEX. And I was curious, like you said that you have internal check on your side, like that you indeed received the tokens. So I guess like that should cover most of the
Yes.
problems. But I was curious about like maybe it does not cover everything, and you may want to restrict the the routing of tokens to some dexes that you that are kind of legit, and I was just wondering about that. Like, there's kind of whitelisting, but I don't think so. But yeah, I was just curious. Like, I didn't dive into that much.
Yeah, that's correct, because you always have a layer that will execute on the DEX, but always going to check the outputs, and it's not going to rely on the outputs from the DEX. Like, say the DEX has a function called swap. You won't rely on the output of swap. We will always check the balances, and we don't check it DEX by DEX. We do it at the end of the trade, because first of all, it's not gas efficient. Second of all, what you care about at the end is, are we still fulfilling the expected amount of user? And also sometimes swaps can be very complex, like you go from token A to B to C to D. So you care only about the D, and it doesn't matter what happens in the middle, as long as it fits with what the user expects.
Very clear. Thank you.
Yeah.
So we have the next question from Andy here. Is the relayer a good place to embed some additional security checks on transactions?
There are some challenges, yes, that the relayers can solve besides simplifying user experience. Like, for instance, let's say we open the DL for everyone. How do you prevent some spam? But those are still work in progress, and especially game theory challenges, where, for instance, if the DL is open, it can get spam. You can protect that with gas, but you can protect that maybe with staking, slashing, and those kind of mechanisms where the relayers can have some skin in the game. A relayer, you can imagine what is a relayer, like an API or like a DEX that wants to be their own relayer and serve this to their users. So it will add this kind of security measures, but also for the solvers, where relayers can spam that network. So maybe this is still something that's work in progress, can protect from spamming. There's no like risk that we have identified, at least so far, of loss, but it's a risk of locking of funds and making the system less capital efficient for the supply side, which are the solvers in this case.
We have another question from Jean. When considering the security activities, including threat modeling, waiting period for audits, and implementing audit recommendations within your development lifecycle, would you say, essentially he's asking what is the amount of time that is spent on the security portion of the software development lifecycle?
I feel like it's, for V6 at least, I feel like it's more than 50%, because we take in extra time. Each time we will have a date, we will always try to re-challenge the system and come up with the edge cases. So that's the moment we launch, and we do that obviously mostly for smart contract, like for UI. If a button breaks or something like the user doesn't like, it's not the end of the world. But for smart contract, yeah, the risk is quite significant. So for V6, I think we are more than 50. I don't know if we're that much as 80%, but something like 50, 60% of the time that was spent only in testing. It's still work in progress.
I think that's a very good ratio. Because yeah, the more time you spend, I think the more bugs you'll find. And obviously there's diminishing returns, but yeah, it's definitely great to see a security focus and an emphasis on that.
I think the frustration from engineers when they're testing is not finding enough bugs, which is the opposite side when building. It's funny to see the reaction. Also from auditors when they don't find vulnerabilities. It's funny to see the reactions. But yeah, it's good. It's a good news. If I put my entrepreneur hat, it's great. But yeah, I think we're taking the right precautions, and I believe this is now a common standard practice in like most major projects in the space.
Yeah, no, and that's a great problem to have. You know, like on one hand, you could worry that the auditor didn't find the bug, but on the other hand, you know, if you're having the top people come in and look at the code and they're saying it looks good, you know, that's a good sign. So
yeah.
Awesome. Let me see if there's any other questions here. I think that is all. Yeah. Thank you everyone so much for your time. Mounir, thank you for sharing what you guys are up to, and thank you, Merlin, for sharing what Morpho's been up to. I am not sure exactly how we want to end things here, but yeah, just want to thank everyone for coming out, and feel free to follow everyone on social media, and yeah, follow along as these products go live.
Yeah, thanks, Elliot. Thank Nathan. It was great, and hopefully we meet you. Are you guys going to Denver?
Yes, I'll be at Denver.
Okay, you guys. Some of
Yeah,
our team members
see you
will be
there.
All right.
Thank you, everyone.
Cheers.
Thank you so much, everyone. That was amazing.
Have a great rest of your day.